Got my morning voice. We are live. Hey everyone. Welcome to another Unity Game Dev live stream. Think that's the title moving forward. Keep it simple. If this is the first time you're joining us for one of these things, Jason and I, my co-host, we're just going to be discussing game development. So if you got any questions, anything you want to talk about that we can discuss, whether it be design patterns or how to do something in Unity, maybe Unity dots, just drop it in the chat and we'll talk about it. Other than that, if you haven't caught my latest video, you should see a link rolling through the chat at some point during the stream. Make sure you check that out. It is actually about a design pattern called the Singleton Pattern. Kind of a famous one in the Unity space, I would say. I can't really speak to any other game engine, but I know that Unity game devs seem to love the Singleton Pattern. And Jason and I are not particularly fond of that one. So if you have any questions about it or never heard of it or you love it or hate it, check out that video. Hopefully it answers all the questions. I put a very pretentious title or a very assuming title, Everything You Need to Know About Singletons in Unity. What do you think, Jason? You think... Is it everything? Well, everything part 2 is coming out soon. But in the meantime, everything else, that's what I'm going to call it. Damn, that I meant to do that. Just hopefully they don't watch this stream, though. Anyway, that's about it. So, yeah, we're going to get started here. Anything you got there, Jason? Before we get in? Yeah, I see. I think you got a smudge on there. You might want to wipe that off. Up in the top left, you got like a rag or like a microphone. Wow, wow, dude, you fixed it. Yeah, you got it. Just a little smudge. Oh no, that would just make the whole gag like useless. Shoot, is he really? Don't tell me that. Jason is muted. Can't hear Jason. Oh man, that's super sad. I wonder why. No. Yeah. Well, if you guys didn't catch the gag there, Jason wiped off his camera. All right, let's try this. I think I was messing with the tracks in OBS, so go ahead, talk, Jason. Say something. Sing us a song.
Can anybody hear me? Please let me know if the audio is working correctly.
Jason sound issues. Well, I'll just wait for the chat to roll through. And my camera died. No, this is just a terrible start to the stream here. Let's see if we can get this working. Anyway, we're talking about singletons. Here I am. I'm back. Let us know if Jason... they probably say...
Can you hear me now?
You're super loud on my end.
Okay, let me just like nudge it down a little bit.
They might be hearing the echo of you come through. Here we go. Now they hear you.
Okay, cool.
Just
cool.
Let us know. Yeah, let us know if there's any sound adjustments we can make. Looks like it's working. But anyway, all this to say, Jason got a new camera.
Yep.
And we came up with that little gag, and it didn't work. But
yeah, just for comparison, it's like here's the after, here's the before.
It's
amazing what a good camera can do. Right?
Here. Now we can talk about game development in 4K, high quality 4K, because that's what we needed.
Exactly. That's what this needed. Just more high quality of our faces arbitrarily when we talk about code.
I remember when I first started doing Unity tutorials, I never showed up on camera. And then when I started showing up on camera, people would just be like, why are you on the, what's up with this? Like, why do you bother showing yourself? What's the point? Which is very discouraging, but I think it looks good. I think that's his Irish lag. Oh, they're talking about lip sync issues.
Yeah. We're going to have to tweak some of it. There's my capture card. There's other issues. It's you'd be surprised how much goes into just recording. Yeah. So we'll call that a TBD sometime down the future.
I was joking with Jason before the stream that our videography skills are starting to outpace our programming skills, and
yeah, we keep forgetting to actually write code.
We should probably develop something.
Spending all of this time messing with sound effects.
Oh man, so cool. Someone asked, have you checked out the scriptable objects architecture talk? Who hasn't, man? Ryan Hipple.
Ryan Hiffel, he's a. Has anyone here watched the show Good Place?
I haven't.
So it's basically there's a running joke in it where nobody knows what heaven looks like, but there's this one guy, some stoner in the middle of nowhere, who got it 100% right, and they were so amazed they have him up on the wall in a little frame, going, "This guy figured it out. He's a genius." And that's how I always feel like whenever someone brings up that talk. It's like we should all just have a little frame picture of Ryan Hipple on the wall, going, "He got it. He figured out how scriptable objects are supposed to be used."
Yes, man, that's hilarious. Although I saw a comment I think my Singleton video about how someone didn't like scriptable objects, how that wasn't meant for that. It was only meant for like configuration style things, not for something like player health that has to be persisted from scene to scene and changed. But I don't know. Yeah.
Well, I admit I have a similar stance.
I figured
that.
you would.
Jokes aside, I don't use scriptable objects in the way Ryan Hipple does. I think the event thing is cool, but it's also very I guess I have an issue with the fact that everything becomes an individual component then. You have to make a literal individual asset for every event, every variable, every parameter. And it's just very heavy when conceptually the point should be things that are like, for example, it's cool for testing to be able to split out every event you might want to fire off. But realistically, you're building a lot of architecture for something that is basically debugging. And there's a reason you don't deploy your debug logs, right? They're for testing at that point. So I would rather build an event system that works runtime and use the sort of scriptable object event system as a way of having one or two unique tests that I could then get rid of at build time. I don't like the idea of using it as the entire architecture for your system because realistically, you're not like being able to click a button in the asset folder to fire an event is cool, but literally you're not doing that at runtime. So there's no point in all of that architecture, you know?
Yeah. And I think for me, sort of the red flag was how when you switch to that paradigm of using scriptable objects, like you have to really lean into it. And it really just becomes how your entire project is architected. And I don't know, I feel like anything like that kind of, it always raises red flags. Like another example would be like using Zenject. Like you really have to lean into that and couple that into your project. And it just becomes such a fundamental part of your architecture that, you know, for better or for worse, I don't know. I mean, I know it works for people, but clearly it worked for him and his studio.
100%. And like they can do one thing that a lot of companies can't, which is go fast. And that's honestly a really good selling point for his sort of solution. Is because oftentimes you need to prototype really quickly and get lots of stuff done. And like, I've not seen a system as robust for doing quick additional events and quick variables that are propagated throughout the app than any. I've never seen a better system for that. I just don't think it's good for a large performant application, especially because every single one of his events is fired using an event listener that he writes himself, which uses the Unity event system. So not only is he doing scriptable objects and variables and lots of memory for everything, he's also using Unity events to dispatch all those around, which are notoriously the slowest of the events that you can use. But like I said, if the point is to do prototyping and get tons of stuff done, I don't know a better system. But if it was for something that's actually a large scalable application, I would rather not. I would rather just use my own short event system with an internal hash map or something.
Well, you know, and I think that's kind of the thing, I guess the fundamental problem I have, and it's a problem that I have that arises a lot in both Unity development and just any software development, that a solution comes out, everyone gets on board, and it's like, this is the way. But I think at the end of the day, you just have to, you know, you have to measure and weigh what it is you need. If you need to be agile, if you need rapid prototyping, you know, I think definitely learn about the technique of using scriptable objects and use it. If you need something more robust, or let's say you have a project with some insane, you know, dependency architecture or whatever, or hierarchy, you know, use something like Zenject that can handle more complex injection scenarios. If you need to be optimized, if you need a project that's going to be on mobile, or you're going to deploy it to the what's that, the Elon Musk's car, the Tesla,
Tesla.
and you have very tight space to put the app out and memory footprint, and so you need to make sure it's optimized. Use Unity dots. I just think anytime you look at something, you watch a video and it's about something like scriptable objects, and you think, wow, this is it. This is a game changer. That should be a red flag, because there's no one cookie cutter solution for all your situations. It's good to learn them all, but
Yeah. It definitely should be in your
yes.
tool set, because I spent the first 2 years of my Unity life not using shippable objects at all. In fact, I spent the first year not using coroutines, and I spent the second year not using shippable objects because they felt like additional features that you didn't need. And once I started to use them, they became invaluable. So I'm not saying don't use shippable objects. I use them all of the time, but I use them for a large set of configurable data, for building up a small database of internal stuff, like kind of very small localization systems, or I would use them for example, I think I mentioned it last time, I did a grid system where I wanted to write them as text files, but I don't want to store them as text files in the app, because then you have to read the file every time you want to parse the grid. So instead, I use that at build time, or at edit time rather, where I have the text file and I'd read it into a scriptable object, and that becomes my in-memory persistent store. So there's a lot of cool stuff you can do with them. It's just the event approach I'm not fond of. The rest of it I think is pretty good. Like it's definitely the preferable way to store data between scenes in Unity. Like I honestly don't recommend saving out to a persistence file just because you're changing scenes. That's insane. You should have your data stored in something like a scriptable object, in-memory persistence between scenes, and then when you need to save, you save from a scriptable object, serialize out to a file. That's usually the approach that I would take.
That seems like a good go. When you were talking earlier, I thought you were going to say, I spent the first year not using coroutines, the second year using coroutines, and the third year not using coroutines.
Yeah.
I just can't wrap my... Not that I can't. I understand coroutines. I just avoid them at all costs. I don't know. I think it's just on principle at this point. But anyway...
I admit, the very first time I started using them, I was like, I already know what an enumerable is, and it's not this, and it bothers me. It's being used in a weird way, right? It's not. This wasn't the intent of it. It was meant to separate out collections into usable individual iterable steps, but it's used to iterate through kind of units of work. Just felt off to me. But now it's kind of almost elegant, right? Like it's a clever way to solve that problem of a non asynchronous game engine. Just they take a unit of work, divvy it up between frames. I think it's a pretty good solution for.
I think it was the right solution, for the time. And now they've got dots and they can do all sorts of asynchronous stuff. That is fancy. Yeah, it makes sense because you really didn't need anything else at the time, and but now people need that for mobile optimization. Now they have another solution, so it's kind of nice. Yeah, give credit where credit's due. Yeah. I like to poo-poo the coroutines, but it's pretty good stuff. Good job, Unity.
Yeah, like to be honest, they're making leaps and bounds. The moment a lot of people talk about dots being a good indication that they're really diving into sort of more performant code and stuff. The thing that actually was my favorite change they ever made, which is I think the biggest proof that they started to care about the quality of the code written in the games, was when they removed the ability to support the dot syntax on components. That to me, I don't know if people remember this, but back before Unity 5, in Unity 4, all of these assets on the store you could just write dot rigid body, dot audio source, dot
okay.
Whatever.
I got the tail end of that. I remember that. Yeah.
And the thing is, what that was doing behind the scenes is every time you called this sort of property, well, it looked like a field more than a property, you just assumed it was something on the object. But again, what you didn't really think about is it's doing a get component call across the board every single time you do that. And they knew people didn't know this. So people would be writing this dot rigid body throughout the whole course of the application and having 50 to 100 unnecessary get component calls. And so they made the very bold choice to remove that feature. And actually in Unity 5, it was deprecated, you couldn't do it anymore. So they had to build a tool that would convert old code to this new syntax and replace all of the dots with get components. And this broke a load of assets. So they did a pretty brave thing of sort of alienating a large portion of the audience in order to move people towards a better and more sensible kind of
Yeah.
structure for code. And I think not a lot of people gave them credit for that. People were just angry that old stuff broke, but they didn't realize the intent was, one, it cleared out a lot of deprecated assets on the store. Because if you're not willing to update your asset for a change from 4 to 5 like that, realistically your asset's probably dead anyway. It's probably,
Oh yeah, yeah.
5 years old and not usable. And so moving to that change was a huge deal. And I think they've done a lot fancier and shinier things since, but that one was the one that I was like, oh, okay, they're making people start to think about what their architecture is based on. You have to now actually concentrate on the fact that it is a component model, and I think that's a very missing part of the Unity puzzle.
For sure. Yeah, it's interesting how that is. People get really hyped up about these features that are have a lot of pizzazz, but then you think, yeah, those changes. I'm sure they're making changes like that even to this day that are going unnoticed, but are very valuable.
Yeah, like optimizing the for each loops now. You can use those without too much of a problem. You still preferentially should be using for loops. They're still mildly faster. But it went from being, oh, there's a ton of garbage allocated to, okay, it's just not as performant as for, which is all these little micro optimizations that are sort of that go by the wayside,
Speaking of optimizations, there's an interesting new syntax in Dots where you create I think a job or something that'll run asynchronously, or rather, you don't have to create the job anymore. So what you do is you call entities.forEach, and you pass in a lambda, and that lambda will get run, on however many processors you have, and multi-threaded, whatever.
Oh, interesting. Yeah, that seems to mirror what Microsoft did with the task parallel library.
It's nice.
So you don't have to do you don't have to make background workers and actually create thread objects and pass stuff to it. You can just say, magic up my threads, please. Make it all work properly.
Yeah, that syntactic sugar that is so valuable. But what's cool about that is that lambdas are actually, they generate garbage. But something they mention is that even though you're using a lambda, when the compiler compiles that particular section, they've done something where it actually will compile it to structs and run it in some fancy, I don't know. I mean, optimization is not my expertise, but it sounded like, wow, that's pretty cool. They added the syntactic sugar without sacrificing the performance, and I feel like that seems to be the trend with Unity these days. They're really going for optimization, and they have to, because their main selling point is that you can easily deploy to any device, and so they got to be able to optimize.
And to be honest, I think part of it too is they're reaching a ceiling on the quality they can hit at the moment, because they've gone from sort of looking okay to looking pretty good to now looking comparable to AAA games, to the point where they have no more headroom until they start micro optimizing to give themselves more headroom to start throwing in ray tracing or whatever it is they plan to do next. So they kind of have to go back and start optimizing the engine to get any better performance.
Yeah, it's pretty cool.
Oh, have you noticed, speaking of structs, there's a whole load of really cool new features coming to C# 8. And one of my favorites being, you can now put the read-only keyword on a struct and define it as a struct where it has it's completely read-only and it's assigned at initialization time. You can actually make entities in memory that are entirely effectively structs with zero mutatability.
That's
particularly cool.
Wow, cool. Yeah, I got to look at that. I never follow up on the new additions, like version 8, whatever, and I always just hear about it way too late, and I'm like, what, you could do this? It's like way too late.
I'm a big fan of I love my syntactic sugar. I always make sure I know well in advance whatever is coming down the pipeline. I take a small bit of pride in the fact that very rarely do I look at somebody write a line of C# code and I go, how did they do that? Now, don't get me wrong, I'll often be confused about algorithms and not know how the hell they came up with a solution. But very rarely is there a piece of syntactic sugar that I don't understand. The last time I was caught off guard was, I didn't know you could do this. You can write type of and then do a class name with a generic key type, but leave it blank. And it will consider all variants of that object with a passed-in generic of any type. That's the one time I saw it and went, oh, I didn't know that was a thing you could do. So very, very rarely am I caught off guard with syntactic sugar.
Well, I gotta catch up. What's your secret? Just follow the change logs.
Yeah, the Microsoft tend to come out with updates on what they're planning. Like, for example, the string interpolation
Mm,
syntax, the $ string, that was known about and demoed back at, I don't know, C#5, I think 4 or 5, long before it hit 6, because they were kind of, they have a blog as well on the site where they try to get people's feedback long before they implement it to make sure people are okay with the idea. And so you'll sometimes catch some of these features long before they hit the language itself.
Timon says that C#8 allows method implementations in interfaces.
Now, here's something. This is an interesting
Yikes.
topic, actually. Yeah, I was going to say that because that was my gut instinct too. But I have to ask the question: why is that a bad thing? Because instinctively it sounds wrong,
yeah.
and because we have this mental barrier that says interfaces are a clean interface of an abstraction, and abstract classes represent base implementation. But we've gone over this before. Java is the only other language that does this, and C# inherited it from Java's design. Other languages like Smalltalk and older than that used to do multiple inheritance of actual class types and not interface definitions. So the idea of having base implementations that could be multiply extended is not new. It was just it was a feature they took out of Java for simplicity purposes because it's very hard to solve the diamond problem. But what's really interesting is the fact that it seems like a weird addition, but I honestly can't figure out why. Because, like, what's the downside to it? Like, I know it feels icky, but honestly, what is the complaint for having that feature?
Because it's different, and I don't like change.
Yes. That's probably the most compelling argument for it. Yeah.
Yeah, no, it's interesting. I guess like without thinking about it at all, just throwing something at the board. It's like I'm a purist, so I want my interfaces to be pure, simple contracts, nothing else. Like you said, I'll have my abstract classes provide some additional, functionality. Like if I need to use the what's that pattern called? Not the skeleton pattern.
Prototype?
Not prototype. It's the one where you
Flyweight?
oh my god, I can't think of it. It's not the skeleton pattern, is it? No, that's not a pattern. It should be. That sounds really cool. But anyway, I'm just being a purist about it. That like right off the bat, I'm just interfaces, they have to be, no implementation. Sorry, now I'm looking up that pattern. Framework pattern? No, it's the one where you can define like the order in which methods are called. So you'd have like an abstract.
Dangerous responsibility?
No. I don't know why I can't think of it. Let me go to that. What's that website? SourceMaker. I love that site for looking up design patterns. SourceMaker design patterns.
I guess what kind of brought me around on the idea is I asked myself what I would normally do. What I would normally do is I would use interfaces to make that clean, abstracted interface with no implementation. And then I would use something like a strategy pattern to inject different strategies to implement those features. But if you think about it, that's me doing 2 steps for something that arbitrarily could be 1 step, right? Because almost guaranteed, if I implement an interface, I'll have a default strategy that I want applied for that unless otherwise implemented. So what's wrong with me having an interface where there is a default implementation provided that I can override if I want to provide a new strategy for it?
Sorry, was that a question? I'm sorry, I was reading the tempo. I was reading that.
I'm just saying, like, imagine you're creating some kind of an entity of a grid actor. So you have a grid actor concept, right? And you create tons of grid actors. You could have something akin to a display position, and it takes in some sort of display printer, and it calls a bunch of methods that says, draw position 0, 0, draw name, draw whatever. And realistically, you want every asset that marks itself as a grid actor to be able to tell you where he is on the map and what his name is. And so doing a very basic implementation, which just says, take the public properties XY, take the public property name, and pass those as a print feature into the print method, that would solve the hassle of having to write 3 or 4 lines of code every single entity just to say print dot X, print Y, print name, because it's like that's the implementation that's going to fit 90% of the characters that do it. Now, how would you do it without implementations and interface? You'd make a single strategy, which is default printer strategy, and then on initialization, you pass that in and you delegate to the other strategy probably. It's a great quick way of doing it. And that just seems redundant, right? You're now instantiating a variable, having more stuff in memory, you're passing it around, and that's a lot more work than just having basically an advanced toString function that's defaulted across every single property you're making.
Why not an abstract class though? In that scenario, to play devil's advocate,
because
so people can catch the whole side, the whole story.
True, that's a fair argument, but here's the thing: the reason why this is needed is because if you could do everything you needed to with an abstract class, we wouldn't need functionality in interfaces. The reason we need functionality in interfaces is because you can't have multiple inheritance. So you can't have default implementation for that grid actor, and also default implementation for maybe like a name or position calculator. Right. Imagine you're doing something which like calculates to a grid. All it does is round out 0 values to map to a grid position or something. These are two functions that are kind of defaults. You don't want to make an abstract class that supports both grid positioning and printing. They're two separate concerns. They should be separate interfaces. But you also do want default implementation for both. So an abstract base class will do that, but now you have to expressly have every single entity have to use that base class rather than just pick, oh, well, this thing will use the default printing method, but it's not on a grid, so I don't need the grid stuff. You either have to go all in or just partially, or lose all of the features altogether.
Which is something that I've run into a couple times, now that I think about it. And it's like,
I think it's one of those things that it feels wrong because we've been conditioned to think of interfaces as this really clean contract. But I guarantee going forward, at some point, it'll just be a default language feature that we don't even think about. Like, for example, I hated tuples when I first saw them. I thought they were
I still kind of hate them, not gonna lie. Item 1 dot item 2. What the hell is item 1?
Yeah, and I can totally understand why, especially because you have this weird idea that you're passing like a return statement with 2 variables. This is nonsense. This is madness. Everything's going to break. But when you see some of the examples they use, you don't actually really make a method that returns 2 variables. You instead make lambdas that return 2 variables and then transform them to 2 other things. You can do some really nice stuff where you use an intermediary lambda that returns 2 objects and recomposes them. The best example I've seen was, what if you have an x and a y coordinate on a point and you want to swap them? You want to set the y to the x and the x to the y. How do you write that in code? You can't write x equals y, y equals x, because what happens is you override one to the other and then they're both the same property. You have to write var temp equals x, y equals x, and then x equals y or whatever, and you kind of go through the cycle. But if you use a tuple, you can return xy, and then in a method return yx, and so you just swap the 2, and it comes back as 2 separate parameters, and it'll automatically support that intermediary variable for you.
Definitely. It definitely has its use cases like that are nice. It's just that when you first see a feature like that, I think your mind goes places that. I don't know. My mind goes.
Yeah, how can this be abused? 100%. Yeah, that's
now what. All right, tuples, sure. What about thruples?
Well, I even have a problem with having 3 arguments in a normal function. Never mind in a return variable.
Yeah, this code smells. I found the pattern, by the way. It's the template method design pattern, where you have a template method in the I was thinking skeleton. That's the skeleton of the method, but template method. So my bad. Cool.
No, you don't need to implement every method if it's got default implementation. That's kind of part of the benefit of it, right? That you can provide, unless you override this virtual function, this is the default implementation. That's kind of the strength of it.
Yeah, it's good stuff.
That being said, I don't think I'll use it very often. Like I'm definitely, like, I'm not shilling for the idea of big interface method, but it's just one of those things that I think there's a purist set of programmers who will very much hate the idea. And I think if you fight your base instinct and go back to what I've said many times before, ask yourself what the point of language features are and what the point of the code you're writing is. And oftentimes you'll realize it's there to solve problems. And if you don't have the problem, don't use the tool that's there, right?
I can't wait to see my first monolithic interface method. that just
Yeah, it's got like 50 implemented features and the whole lot. It's basically a class. You just
it's
called it interface
basically a
for no reason.
class.
Yeah.
I cannot wait. uh,
It actually brings up a good point, though. I definitely think sometime in the future we need to sit and actually have a really big discussion on
mm,
interfaces. Because I probably mentioned this before, but interfaces to me are probably my favorite topic.
really?
The reason being, oh yeah, 100%. Because when I was learning programming, so this may sound like a humble brag, but it's not. But my first year of programming, I killed it. I was amazing. I went in, I thought I might suck at it, and I was top of my class, 95s, 98s, across the board. The only reason I say that is because in my second year, I remember talking to somebody and saying, interfaces are stupid. Why do we need interfaces? Now, this is somebody who's
Oh
top of
my
his class,
gosh.
doing great, reading stuff at the free time. Like, I didn't understand what they were
Mm,
for. And then at some point, I had a eureka moment. I went, oh my God, these make perfect sense. I get what they're important for now. And it completely changed my perspective. It's like it gave me that eureka moment where the way I approached software development drastically changed once I understood what the word abstraction meant. Not the keyword itself, but what is the architectural concept of
yeah.
abstraction? How does it apply to code? And I think Unity's design has led people into a position where they don't have to ever think about that.
Yeah.
And like you think in terms of components, but components are almost like a set thing. People think about it like they've got a table and a component is a knife or a fork or a plate or a dog or a cat. Like they don't think of it as an interface abstraction could be a damageable thing, a thing that can move. Like you can make these really declaratively abstract interfaces, and how you can interchange those and do fun stuff with it is, I think, a game changer for people once they understand how it works. I really do think that would be a good
Well, now
design.
that we've got the serialized reference attribute and we can actually serialize interfaces inside of mono behaviors, I think
Yeah,
now is the time to do that sort of video. So yeah.
because I was coming up with an example. I was talking to somebody last night, and I think there's a common mistake I see people make with interfaces where they picture it, they kind of do it in reverse, right? They'll have a class and they will look at what features a class has and they'll like make an interface out of it. But the
Mm,
example I used is, imagine I had an interface called navigatable, the navigatable
hmm.
interface, and it's got up, down, left, right.
Yeah.
Really vague. Got a method called up, method called down, method called left, method called right. And I hooked it up to a class that says navigatable controller. And if you just press the up, down, left, right on the mouse, WASD, or on the mouse on the keyboard, it will just do whatever that thing does. Your instinct is, I'll make a character, I'll make a player. And if I press W, he moves up. If I press B or S, he'll move back. And so on. It's a very basic implementation. But what if I took that same interface and I put it on a UI menu? All of a sudden, the
Hmm.
same interface, WASD, doesn't control a person, but controls the movement of a mouse cursor on a menu. And what if I went one step further and put the same interface on a music player? All of a sudden, up changes the volume up, down changes the volume down, and left and right change tracks. So, in that way, the idea of a navigatable concept is not a movable character. It is the thing that promises to conform to a vague shape of up, down, left, right. You can apply it to anything that is able to conform to that contract. And I think that idea is firmly missed by a lot of people in programming. I think covering the idea that you can have nonsense interfaces like the classic command pattern, which doesn't mean anything. The command pattern technically is nonsense, but it's amazing. So I think that's something we should really
Yeah, for
cover.
sure. Someone brought up, Ravanan brought up, he wants us to talk a little bit more about serialized references because he just doesn't get it. And I think this is going to be a common thread because even in that video that I did about the 2019.3 features, a lot of comments were just like, I don't understand what serialized reference is even for, because I just don't think that a lot of Unity developers who come from like an artistic background or a background other than programming, they don't think they ever even use interfaces. So I think, yeah, definitely to talk about it. I brought up Unity over here. I don't know if we should throw up some code, but essentially, I guess the first question to ask, when you're diving into understanding what a serialized reference attribute does, is, do you understand what interfaces are, and do you understand what about polymorphism and the ability to inherit from a class? So
And I hate to be that guy, but a lot of people will say, I understand polymorphism. You might understand the keyword, and you might understand like, oh, I get it. Cat and dog are both animal, and then animal is a creature, and people can be. You may get that concept and that relationship, but there's something deeper to that idea where it's like the difference between someone saying, I can teach you the alphabet and you understand letters. You can say, oh, B, I know what a B is. Yeah, there's a D, I get that. But that's not the same as knowing how to write prose, right? Like you can know the keyword, you can know how they connect, but there's a big difference between that and understanding how to apply them in rules and do interesting things with it, you know?
Sorry, my cam died. I'm trying to fix it real quick. All right, I'm back. Yeah, so basically, I guess just to real quickly pull up some code.
Yeah.
This is some code I threw together for Sunday's video, but basically, let's say you wanted to encapsulate, I don't know, health, because I have this example here, and you said, well, instead of having health be an int, this might be a bad example, so please stop me, Jason, if you have something else. But let's say you were like,
well, I say damage is easy, okay. Right? You can do damage as a quick
damage is fair. So let's say you had an interface damage that represents what, how you what am I doing wrong here? Oh,
you're giving it a name when it's just an interface.
Stream coding, it ain't good.
It's fine. Yeah, don't worry, it happens. So yeah, so we have this damageable thing, right?
So go ahead.
And we just have a function for doing damage called damage, if we like.
Do damage.
Well, I would call it damageable as an interface, and then take damage would be maybe or even just to damage, because damaging is like damage is a function,
I think
right?
Let's do damage. Something. High damage. Although whenever I do interfaces like that, I do like the able, like damageable, movable.
Oh, that's what I do. I do the interface name is damageable, and the method will be damage.
Got it.
Because then you're saying person.damage, right? You're damaging the person.
So we have an interface here. Damage. Okay. So now we can make this guy inherit damageable, which means he's going to need to.
But we'll need to have a parameter inside of the damage function on line 7 to take in the damage quantity.
Okay. Let me know if I need to make this code any bigger or larger. I can zoom in a little bit if that's too hard to read on the stream. Okay.
So this is the bit that I think is an interesting idea, right? So already this is such a small thing, but I want to point this out. A player conceptually has health, and a player is damageable. Now, when I say that to you, you're probably thinking, of course, to be damaged means to lose health. That's an implicit connection. But you could have a other system where you have a crate. You create just a crate object, and a crate might have like physical integrity or a bridge or something. And if you have that object, it could also extend from or implement damageable. And in this instance, crates don't have health conceptually. It's not really the same thing, but it might have like a robustness quantity,
or maybe
something.
It just blows
and
up.
If it hits 0, or even if it blows up immediately, so any damage will break it. And so the idea is damageable is not intrinsically tied to health. It is the thing that can happen, and losing health is one implementation of that. And so anything could be damageable. Like you could later on build a system which is like, emotions, and whenever it receives damage, it feels sad. It doesn't matter. Like the point is, all you're doing is saying, can this thing conform to the concept of being damaged, not that it has health or a number that must change, right? You could even create a reverse world where receiving damage in fact heals things or something. It doesn't matter because all you're doing is saying it conforms to whatever that concept.
So to bring this back to the serialized objects, let's just pretend I had a class that, or a mono behavior that was like the damage tester, whatever. And it was a mono behavior. What I could do now is I could provide it a list of damageables. Damageable. You couldn't do this before. So what am I doing? Sorry, damageable.
Okay, is it serialized field or serialized reference?
Serialized reference. Dude, I'm already messing up. Well, let's pretend I didn't do that. Let's say I had this thing called damageables. Damageables, right? And somehow I provided a list of damageables to this mono behavior. Well, whenever you would save the scene whenever you would play the scene, if you change this list and you stop the scene, it wouldn't be able to serialize this list. It wouldn't be able to save it. So the next time you started the game, it would be completely different. Did I misspell this? Damage. I totally did. Damageables.
And so just to explain what Charles is saying there is the way things get saved, whether it's Unity or anything else, is generally a topic called serialization. You're turning it into something that can then be persisted. And the way you do that is you literally go through every individual part of it and put it away. So a good example of this would be if you're moving house, you create a box and you go through every item and you put it in the box, and that box can now be moved somewhere else and unpacked again. Now, the problem is if you use interfaces, you're not defining what's in the house, so you can't make a guaranteed promise that you'll put everything in the box. So the point of an interface, the reason interface has been a problem in Unity up to this point is because if an interface doesn't tell you what the properties and fields inside of it are, like that's the point of it. It hides that stuff away. So Unity doesn't know how to serialize that. It doesn't know what's in it, so it doesn't know how to save it. Now, there's hacky workarounds, like there's literally a serializable interface that's a bit meta that actually uses that concept to save itself, where you tell the object, I don't know what you are, but figure out how to save yourself. That's kind of cool. But without getting into too much detail, the way Unity works is the inspectors actually serialize all of its content as you go. So if something isn't serializable, it won't show up in the inspector. So that's why we couldn't use interface in the inspector, because it would have to have been serializable to be used in the inspector. And up until now, Unity didn't know how to serialize it. That's where we're at now, and now we can potentially serialize.
Right. So at runtime, let's pretend that I was adding to this list. I was calling from some other classes from other model behaviors, from other game objects. As the game is going on, I'm calling this function add damageable, and this list of damageables is growing. But if I stop my scene and replay it, all those damageables that got added as the game progressed, in my last play, those would not have been saved. Now, if we do want to save those, what I can do is I can mark it with the serialized reference attribute. And what will happen is I can run the scene, have my code as I play, start adding damageables to this list. I can stop the scene, and then this will be serialized, meaning it'll be persisted and saved. So the next time I run the scene, this list will have all those damageables in it. And the key here is that it's an interface. Now, before, if this was anything else, like for instance, let's say I made it just a list of crates. A crate is actually a class, so it's a strongly typed class. So if I did the same logic, change it to crate, now without doing anything, without the serialized reference attribute, I could run the scene, add all the crates I want, stop the scene, and they will get serialized to this list, so that the next time I run it, all the crates will be there. But again, going back, if I wanted to make iDamageables, which is this is that polymorphism that Jason was talking about. The great thing about having an object-oriented programming language is that I don't need to know if it's a crate. I don't need to know if it's a player. And more importantly, I don't even need to know what happens when it gets damaged. It's not the point. The point of this damage test class is that I'm just going to collect a list of damageable things, and I'm just going to damage them when I call damage all. So let me.
I've been trying to come up with a good example, and I think I have one. So if it's okay with you, Charles, if we could make a new empty script, just a new empty file, and I want to see if I can hopefully explain this concept.
Jason's example.
Ooh, fancy. So imagine you own a company, and it's like Amazon. It's like a delivery company. So let's make a class called Delivery Company. Yeah. So we have some products. So we'll just make a class for product. It's a product that we sell. I'm going to keep this vague because none of it matters. I don't want people focused too much.
Is it Amazon or is it is it Best Buy? Oh, sorry.
You know what? If you want to call it Best Buy, go ahead. I don't mind. So we have a product that we sell, right? So someone buys the product and whatever. So let's make a function in Delivery Company for buy product. Taking a product and then we'll pretend we do a buy function. So maybe do a comment and say do buying code here, stuff. Whatever that is. Yeah. Now, once you've bought it, you have to ship it to the client. Now, how do we ship something? Well, let's start very simply and figure out what the contract is for shipping something. To ship something, we need to know what it is we're shipping, where it's going, and how long you have to deliver it. So let's make an interface called deliverer. And it just has a single function called deliver product. And it will take in a product. It'll take in so just say string location. We'll keep it really simple for now. And then a int deadline or something, whatever it is.
I'm trying to think of the actual term they use. Estimated whatever deadline. That's when it's going to go.
So now we have this concept of a thing that can deliver stuff for us. So if we were to make a constructor and inject that in, should I bother or should we make it in line? We'll do it injectors. I don't want to think about making variables. So do a constructor on the delivery company. Now this is technically getting into a version of control. Don't think about it.
Just go with it.
Just go with me. Go with me for now. So yeah, we've got this deliverer and we're passing a deliverer. So this delivery company knows some guy will do delivery for him. Now, so make a private field for that deliverer and then call it in the byproduct. And just pass in whatever generic variables. That, after this, we can get to the actual point of the exercise. Yeah. And then product, and then just, pass in just... Yeah, and then...
It's going to get here in...
Pretend it's 2 days or something, whatever.
2 days, yeah. That sounds about right for Atlanta.
Right. So, what we've got here is the delivery company can just continue doing his job, which is getting products, dealing with customers, and once all of that's been done and the purchase has been done, they say, hey, deliverer, this is the thing, this is where it's going, off you go. And what's your assumption about how that's being delivered? Well, most likely it's probably delivered by a delivery van. So let's make a delivery van class that implements iDeliverer. Right. So this is the point. We don't need to implement it. That's fine for now. This is the default of what people think interfaces are. This is straightforward. I have a promise for a contract. I have a thing that can deliver stuff for me. But here's the interesting thing. We are not referencing a delivery van inside of the company. We are referencing a deliverer. And so we're making literally no assumptions about what a deliverer is. So at the most basic level, it can be a delivery van. At a more complicated level, it can be a delivery network. Imagine the delivery van, instead of having one van, is actually there's too many products, or the product is too big, or maybe it's going across the ocean. That delivery network could internally, first of all, use a ferry to get to one part of the country, and then use a car for the next bit. And none of it matters to you because all you've said is, here's a thing, go deliver thing, and you're leaving all of the implementation up to whoever else job it is. So it could be the product could be split across multiple vans. The product could be moved between 4 or 5 vans and the deadline divvied up between them. I've seen another example of this, by the way, where someone talked about painting. You could have one person paint a house, or you could have 5 painters paint a house, and it doesn't matter to you. You've paid a painting company a certain amount of money to paint a house. So you are completely leaving that decision up to somebody else. Oh, you're getting fancy.
Well, I just wanted to show what I look like. The point
showing off.
The point being that you can even have. I mean, you can even have a list of iDeliverables nested in here.
Yeah, you could have a network that partitions off a part of it to another delivery network because it's outside of their region or something like that. You can go crazy.
Oh yeah, you could have like region 1. Or you can do a dictionary. Yeah.
But here's the bit I wanted to get to. Here's the thing I wanted to kind of highlight. So we'll take that for granted. That one works. Imagine it's in the future and our delivery system has been out for a long time. Somebody invents teleporting. Teleporting has now been invented as a new concept. We've got this existing system that it's been around for 10 years and we've been using it quite comfortably and everyone's quite happy. Now we can make a teleport deliverer. And then, and now we don't even know about this. Our system that never even knew teleporting was available is now able to deliver your products by teleportation. And our code doesn't change because the concept of teleporting is has been added after the fact and injected
Because when
into
we
our system.
roll
The
back
reason
up to
being,
the actual delivery
yeah,
company,
go all the way back up here. It doesn't say
yeah,
teleport anywhere because that's not a concept that was ever conceptualized at the point of
doesn't
building
have to
this
know,
system.
doesn't care. It just says, "Hey, I got a teleporter. That's pretty cool. Whatever."
Yep. And that is kind of the point of interfaces. You're not using an interface to say, oh, this thing has these features. You are saying this is the minimum specification required for me to do my job. Please go do this. Give me back the thing I need, and I'll continue on my way. And then you can inject in anyone who's able to perform that job. And so if you think about it, this is like anything, right? If you wanted food, you could say, get me food. I don't care what happens. That could be your friend making you a curry. That could be ordering from a takeaway service. That could be, having a sandwich in your lunchbox. Conceptually, your contract is food on table. I eat food. I don't care where it came from or what happened. And so, anytime you can extract out that concept, you'll give yourself the freedom to do a lot
Yeah.
more things. And where it gets really, really cool is an interface. You can have multiple inheritance, which means something can be deliverable and damageable and healable and whatever else you want. And all of a sudden, you start to stack behaviors in confusingly interesting ways. For example, I think it was the War Fortress gave the example that they had containers of water. So you like a canteen of water, and it had some interface like a water container or contains liquid container, and you could say, "Here's liquid, give it to the container," and the container now has liquid. But later on, they added the ability for people to get drenched and have water in their clothes. So, as weird as that sounds, your clothes could inherit from contains water, and you could add water to clothes, and that was never conceived of in your original spec. You were thinking of a water container that holds water, but technically, clothes are a thing that could contain water, so you can add that feature, and anything that could basically make something wet can now make clothes wet just as much as they could make water, make canteen wet from being with water. So there's these really weird things you can do, and I guess the point of the exercise is if you don't use interfaces, you have to come up with and account for every conceivable feature you might want down the line. If you use an interface, you can say, not my problem. Somebody else will figure that out later. And that's the power of it.
Yeah, that's definitely the power. And to roll back to this player class to show it in sort of like a gamey type example, a classic one is the damageable. And now with Unity, what's really great is, and this is probably serialized reference you might use for more complex things, like for instance, if you're creating some sort of like a grid structure or tree structure, that's like an example that I've seen a lot. But I mean, this is something that I've run into where I'm like, well, I want to have my code nice and make my boundaries, so my damageable items will be over here, but now I can actually reference a list of all my damageables, and in my game controller or something like that, or maybe like what was the interface you were just saying where it could get wet? What was that called? Like
Yeah, it was like
wettable,
a water container or something.
something
Something
like
weird like
that. You
that.
might have a class that's
Well, a good one, weapon. How about
okay,
weapon, right?
weapon.
You could
Yeah.
have a list of your weapons, and your assumption could be this could be a melee weapon or it could be a gun, and it doesn't matter to you because you're just saying weapon.use, and it doesn't matter whether it's an entirely different conceptual system. It could be a magic spell, so you can completely change the implementation, but make a list of all of your things that can conceptually be used as a weapon. And if you want to make a spoon a weapon later, you can do that, and it doesn't actually change
Oh,
your
here's
code.
one. Equipable, or rather, iEquipable's one. But I was thinking like an inventory. You might have an
Yeah.
inventory item, and how that gets added to your
Yeah, and
inventory.
you could have a backpack could have an inventory, a purse could have an inventory.
Yeah.
You could have a dead body could have an inventory of, like, you could add inventories to literally anything
Yeah,
conceptually.
for sure.
Yeah.
So yeah, that's that. Those are interfaces.
And what one comment regarding a question here: should we always strive to extract interfaces because you'll never need that because you will never be sure in the future? No, technically, so I may have made it sound like go ham, add interfaces everywhere, but I want to put a caveat there.
Always a caveat. There is always a caveat.
Yeah, always a caveat. Interfaces are for how do I phrase this? So everything you do in code is collaborators. So the word is collaborator in general, and that basically means you can't do it all yourself. Somebody has to do a part of it for you. For example, if you're making a sandwich, you have to have a collaborator that will make the food, collaborator who will deliver it to you, and then you may do the preparation work, but you can't manifest that stuff out of thin air. Somebody else did that for you. So what you do is you make an interface to describe the behavior of a collaborator, and you only do that if there is a reason that if you think down the line there might be a different collaborator. So if you get your food delivered from a certain source and there's a good chance down the line that source could no longer exist, you don't want to depend on it and you don't want your system to break when that source doesn't exist anymore, you would say food provider get food and you would make that an interface. You don't arbitrarily turn everything into interfaces. You say, is this thing something I'm reliant on that I cannot 100% guarantee will always be available, or that it might have new, more fun features in the future that I want to make use of. So I would say it's good practice not to even start with an interface. Make the code, make it work. And for example, make a player that can take damage. Then later on, make a crate and it takes damage. And then you can go, hang on a second, both of these things take damage. And then you can look at that as, can I start to like pivot my code in such a way where I take the concept of damage out and I start making that this discrete thing that everything else can interact with. So I wouldn't aim for interfaces. I would let the code kind of tell you it needs interfaces. That takes experience and it's hard to do, but if you see them often enough, you'll kind of get used to
a good
that
rule
idea.
of thumb is the rule of three, where if you have to do the same thing once, twice, the third time is when you genericize it. And I highly recommend that, because even at the level of experience that both Jason and I have, even I fall into the trap of over engineering, like right off the bat. And the thing about over engineering is that you will often end up with a system that's more complex than your application needs, which any added complexity is, I would say, bad, because any added complexity makes the job of the programmer more difficult. So you want to try to strive for simplicity. And then the other thing I was going to say is that sometimes you don't really know all of the you don't really know how it's going to manifest. And sometimes you'll lock yourself in. Sometimes by genericizing, you will lock yourself into specificity, which is insane to think about. But I've done this a million times.
Then you panic and you add a feature to an interface, which suddenly breaks everything, and you have to go back and rewrite 10 classes because you've decided that the movement code actually now needs to know about the size of something to make sure it can fit in certain gaps or something. And all of a sudden it's like, oh God, when I wrote move, I just wrote move and a vector. I didn't think I would have to take into account the size of the object. And all of a sudden every single interface, every single thing that implements an interface has to change.
You got if statements, switches, you've got like a million arguments into one method to account for all these little things. Yeah, you're like, oh, size. Well, shoot, I got to take gravity into factor. Oh, I'll just pass gravity in and I'll ignore it if it's on this class. There's all sorts of things like that really. So rule of three, just do it twice. The third time, take a really hard look. And even, I wouldn't even say the third time you genericize it. Just the third time is when you start to think about genericizing. Then the fourth or fifth time, you'll have a nice couple classes to play with, and then you can start thinking, well, I can genericize at least this little piece, and then go from there. Everything you do should be iterative, which speaks to a whole different, conversation to have, and a video that I need to do.
Now, this is sort of a slightly more advanced topic, so I don't want to go too far into this, but also make sure you don't get into the bad habit of downcasting everything. So what I mean by that is, once you have this idea of something as being damageable, it might be very tempting to make the vaguest methods possible where something takes in an I damageable and calls damage on it. And you're like, great, it's damageable now. But damaging might also need to flash the texture or change colors or do something interesting. And for whatever reason, you might need access to other properties on that damageable object. So just because something implements I damageable doesn't mean you have to pass it around as an I damageable object.
That's a great point.
So for example, with the whole grid character, you could have a character who walks around on a grid and attacks. You might be tempted to cast that thing down to an I grid guy who has a position set, and that's the only function, set position, 0, 5 or whatever. And all of a sudden you're like, oh no, I need to access the fight function on this object, but I can't because I've turned it into the most abstract concept of a grid item with no knowledge of what it does. So whenever humanly possible, keep things at the level they're at. The only time you ever go down a level and sort of make it bigger is when you want to work with a system that wasn't intended to be used with this object. This is really hard to explain, but what I mean is interfaces should be used to give you maximum flexibility to interface with as many different concepts as possible. The best real world example is a plug. If you had a wire coming out of your wall, you could only ever use whatever that wire attached to. You instead have a socket that things plug into. The socket doesn't make any rules other than it is this shape, providing you conform to this shape, it plugs in. In fact, that can almost be a downside because you can plug in something with different voltages and break the item that you plug in. But that's what I'm saying. An interface could have been more specific and added rules where you had to like dial into the wall what the voltages of your items are. But you get into these really weird scenarios where stuff isn't worth the complexity. It makes a lot more sense to say, this is my object. It is a toaster, and it happens to support pluggable in interface, and I can then use that in a house object or a aeroplane bathroom object because it has a plug socket that I can plug into. And it may never have been intended for that use, and it may not work as the best case scenario, but it's adding flexibility, not taking it away, right? You're not saying it has to be just an iPlug-inable. It is a toaster that has various different features. So yeah, this is something that I think we'll need a video on expressly because it's a particularly vague topic.
I wrote an example of what you were saying just now about, downcasting. It's like you might have a crate damager that needs to play a crate explosion, a damage text.
There you go. Yeah,
it's perfect. Okay to pass in just the crate and call damage. The crate could be damaged one way or another, so you can call that and do everything.
Yeah, because you could potentially have like a number of boards on a crate that have broken off, and you might want to like get a list of those or something. And you wouldn't be able to do that if it was just a damageable and not a crate object or something.
Wow, that was good. That was a good little tangent there on interfaces, and you gave me another video idea.
Yeah, exactly. Just add it.
I see some questions. Before we dive into that, I got to be a YouTuber here and say, maybe I can write a method for it. Let's see. What do we got here? I got it. Let's do an interface. Public interface I likable, right? And then you might say like, right? Or what is it? Yeah, I guess like. And then I don't know, what do we got? Public, void, we got a class that's oh my god. That is a video. I can't type. This whole joke is going down the drain because I can't type. And the video is I likable. Huh, interesting. Maybe you guys should smash that like button. Wait, let me smash that like button. All this to say, if you like this video, why don't you smash that like button for me? Call .like on this video, please. Sorry. All right, so we got some more questions in the
as we got to the last video,
invoke that like function. Yeah, I need to actually prepare something ahead of time that I can pull up. Oh man. But anyway, like the video if you enjoy it, and let's see what else we got in the chat. I saw one a little higher up that we kind of missed. Let's see. Honestly,
one of the questions here is, can you avoid boxing with interfaces? Not really. Like that is the unfortunate trade-off, right? The idea is you are literally shaping something into something else for the sake of maximum kind of mutability and sort of maximum compatibility. You can't really get away with having all of that amazing feature and also maintain that sort of referenced object. In fact, actually, without getting into another whole big tangent, if you're implementing the equality operators, you can technically just have an equality operator that takes in a generic type of system.object and it'll work. But every single time you call equals, it will have to box that object. So you should also implement equitable, I think. And it has a version of that function that takes in the explicit type. And you don't just do that arbitrarily. You do that so that the compiler knows if I'm comparing two identical types, I don't have to downcast it to an object before I compare it, which causes that unnecessary boxing. You can't really prevent it, but what you can do is ensure whenever it makes sense to do so, have methods or interface methods if you like, which don't use the interface types expressly. Like I said earlier, you can have an interface type which has a generic or something, and it implements something which has to have the exact same type as the class. And by doing that, you avoid having to change its form before you do any work on it. So it's a bit vague, but my point is you can't really avoid it, but the best you can do is try to literally use the interfaces to give you functions that let you act on objects of the same type. So I'm pretty sure that's not helpful, but best I can do until we come up with a video to explain it.
Yeah, it's definitely on the list of videos. Another video I want to do is a video on boundaries. You know, just defining boundaries for your
Like boundary lines in the
boundary lines in
application.
the applications, because you know, I think that's definitely something that isn't really discussed, I think, in you know, strong terms like that. And
Yeah.
and I think it's something that a lot of people deal with, game developers, Unity game developers deal with, because there is a lot of opportunity for crossing things over, crossing your streams, you know.
Yeah, between like the UI
Oh
layer and
my god,
persistence layer and that kind of
audio
stuff.
and
Yeah, yeah.
animations. How do I? Yeah. So and that's I don't know what percentage of this it is, but it feels like a high percentage of monolithic mono behaviors are because you take something like a player and you're like, well, it's got to know about everything. It's got to, you know, how do I play the sounds? How do I change my animations? How do I take in input? You figure I'll just drop it all in the player class. It seems like the obvious play. And then all of a sudden you've got like a 900 line player class and that you can't refactor for the life of you. So yeah, I definitely want to do a video on boundaries. So we've got interface video, boundaries video. There was another one. I already did one on singletons, but I'll have to do another one on singletons now. Because evidently I was missing some things. You want to talk about that?
Yeah, why not? I guess the main thing that kind of I was struck by is that uh, you didn't mention the relationship between singletons and um, sort of dependency
Mm-hmm.
injection, because the we had this discussion before where just because actually I think the best way to phrase it is somebody asked the question in the Discord: is a singleton the same as a static thing, static function or
Yeah.
static method? And I think that's a common
Yes.
misconception because singleton has the word single in it and static implies static
Yeah.
or one, and it may sound the same. But I think what the video was missing in my mind was that things can be singletons without actually having anything singleton-y about them because all singleton is something which there can only be one of during that life cycle of the
Yeah.
application. And so you can have something that for all intents and purposes could have 50 of them, but you implement it in the application in such a way that there is only ever one
Right.
of them. Example being an dependency injection framework where you mark it as serializable as opposed to transient.
Yeah. Well, what's interesting about the singleton pattern and the thing that I keep bringing up, but it's such a strange thing, is that the singleton pattern as it was defined in the Gang of Four, their book, you know, which is the Bible of
Mm,
design patterns, is that it actually also has to be globally accessible.
yeah,
And so with you're right in that example that, you know, with the dependency framework you can just mark something as single. It is missing that other little aspect of being globally accessible. So technically isn't a singleton anymore, but it really just gets
that's
it.
fair. Yeah.
If you're using a dependency injection framework, you're probably not using singletons at that point.
Yeah, it's more life cycle management than technical singleton. I guess it's single instanced but not singleton.
Yeah, as
Um,
defined by the Gang of Four, you know, which you take with a grain of salt. I mean,
but I guess that distinction is kind of why a lot of people have an issue
yeah,
with singleton, because singletons are often called anti-patterns as opposed to patterns, because the idea being that they negatively affect the life cycle of your code and they make it
yeah,
harder to maintain. And that can be true, and I think that distinction comes from people not knowing the difference between a singleton and a single instanced item, like the point of the architecture versus the literal line of code that says private static
yeah.
instance.
Yeah, and it's like when you the biggest my biggest gripe with the singleton is that, just like we talked about leaning into certain frameworks like you know, or paradigms, you're putting a piece of code that like is compiled into your class, like it's fundamentally limiting this class to a single instance, as opposed to if you just control it yourself with like a dependency injection framework, or just your own poor man's injection where you just make sure that you never new up another instance. That you're definitely get more flexibility. Once you put a singleton in,
And
you're
I think,
basically saying there's nothing I can do at this point. I'm locking myself into this forever.
and just to cycle back to an example we had earlier, that's like our delivery system having van dot deliver items. And that sort of example where we added teleportation later, we wouldn't be able to do without refactoring our company to support that feature. And that's like saying we'd have to actively change how our company works just because we've got a new provider that can deliver stuff for us. It's kind of an insane concept if you think about it that way. So the point of not using interfaces, or not using singletons, is because you can have that level of extensible freedom later, which you don't have if you lock into a certain implementation.
All right, so let's take one more question. I feel bad because I keep seeing Backbench Game Dev dropping this question, and we're always like, we've been deep into conversation about other things, but we'll just answer this last question and wrap it up. Before we do, smash that like button. So Backbench Game Dev asks, what do you guys think about when and where to use events/actions and delegates? How often do you use them in a big project?
In my mind, that question is how long is a piece of string? It's one of those things. There's not enough information to answer that question. There's varying use cases with varying different parameters, and the unsatisfying answer is use them when you need to, where you need to. The question becomes how do you know when and where, and that comes down to experience. And we can go over some things that'll help you figure those things out. But at the end of the day, events and delegates are just ways to talk between two classes. The way of decoupling this relationship where things need to know too much information about each other. And that is just one of many tools at your disposal. You can use observer patterns, you can use pub/sub, you can use interfaces with injection, you can use strategies, you can use a million things that do the same kind of job. And it comes down to what do you need it for? Which benefits do you need? Which costs are you willing to pay? And it's not something you can give a one-line answer to.
Yeah.
In general, the best advice I can say is if a system theoretically is entirely self-contained, does something, and then spits out some output, whether it be an event or whether it be a finished object, you might expose that output as an event. That way, you could have something. For example, I built a system which would, you could take photos. That photo would be scanned for machine learning, and it would figure out what objects were in the picture, and then it would give me a list of the items in the picture, and then I would go and do something with that information. I built a system where I had an event fired whenever an image had been scanned and information has come out of the scan. That way, I don't care who initializes the scan or who says, take image, look at it, say what's in it. I'm just listening for whatever comes out the other end of it. That's a good candidate for an event because it's something that is a discrete thing that happens at the end of some task. And I could take that image recognizing tool, move it to a different application, not take photos, but instead iterate a folder of photos and still listen to events, and all the code still works, and it still keeps all of itself neatly contained. That kind of thing is a good candidate for events, but it's so hard to come up with. Like, I can't give you a 5-step rule checklist that you can figure out to tell every time you need to use an event. It just comes down to how and when you need to use it. And did you have a better idea, Charles? Because I can't answer that
I was trying to
question.
think of the opposite. Like, when would you absolutely not use an event? And I think in a case where you've got two classes, two objects that are allowed to know about each other, and the logic that that runs between them, the collaboration that they have, I guess, to speak at a higher level. Let's say you have two objects that are collaborating together, and
That's a good point. It should be directly proportional to how close the relationship
So
is. Further apart, the more events are practical. The closer together, the less.
Yeah, I think it becomes a function of the distance you want to put, the boundary, if you will, you want to place between two different classes. And then another thing to consider is, are we talking about a synchronous action that is very short or small, or are we talking about something that is a long running action that I need to wait on, for instance? Another way I've seen this question come up is like for interfaces. do I need to, let's say I have a health bar, am I going to listen to an event, player got damaged or did player damaged, or can I just get a reference to the player and just on every update look at player.health and update my health bar? And again, it's one of those things where it just really depends on your situation. And so
I think another one is a good example is one-to-one versus one-to-many.
Okay, yeah.
If you're doing a task where it's, process a thing. So, I give you a letter, you put a stamp on it, you give it back to me. It's a bit arbitrary for me to listen to events of you being finished putting stamps on things, and then I hand you a letter waiting to get my letter with a stamp back, when it would make more sense to sort of say, that's just a one-to-one thing. I hand you a thing, I get a callback function would be a good candidate for that. Do thing, come back to me when you're finished precisely with the exact single thing I asked you to do. An event would be more like a bell in a shop door. Someone has entered the shop. It's not a one-to-one relationship. You need to be aware whenever anybody enters the shop. It could be one person, 10 people, whatever. And it's not like you're dealing with one person at a time. It's more just in case I need to be aware of the door and the things that happen about the door, separately from this is a single task one-to-one.
Yeah, definitely. So I think it's a function of boundaries. It's a function of, how, if you have to wait for something to run, if you care about this collaborator and some action that it does, and you need to react to it every single time it happens, or if there's definitely a lot to consider there. And so, yeah, how long is the string? How do you answer this question? Unfortunately, like most programming questions like this, it really depends.
And also, like, there's an undercutting problem with pretty much this entire everything we've talked about up to this point, which is that the more architecture you add, predominantly the less performant your application is going to be. And that's usually fine in a normal application because you're dealing with event-based stuff. You're dealing with I click button, I type some values in, I press OK, I scroll through, and everything's done in this slow, event-driven way. Games are fast-paced, constantly running, updating stuff, varying different things. And so you don't want to put in all of those layers of application architecture when it's not necessary. And an event is slow by nature because you are caching a function reference and you are calling it when you need to. And that might be a list of function references. And all of a sudden you're doing more work in distributing messages. I guess the best example is like Chinese whispers, right? You could have a network of people where you tell one person something and it goes round in a circle and every one person tells everybody. It will take a long time for everyone to be updated. But it's less dynamic to just say, hey everyone, this happened. But it's faster and it takes less effort for everybody involved.
The drawback is you got to know everyone you're whispering to.
You have to know everybody. That's the thing. So you have to figure out really when and where that's valuable. It's just making this stuff up as I go.
You're either A, you're in a room and you can see everyone you're screaming at, or B, you're whispering into a phone and you have no idea who's going to know about it.
Yeah.
But you just have to know that your whisper may not get to everyone as quickly as you might like.
Or maybe if we're not talking specifically about events in that way, you could say it's like writing 10 letters and sending them to 10 people. You're having to like go through all the effort of writing the letters and distribute them versus shouting out the window and hoping everyone hears. So event architecture by nature is going to be slower. And so I tend to not use it for things that are loop based. And that's why I don't like things like, I'm not a fan of how Unity is now doing input with this event dispatching stuff. Now, it's not really that slow, but it's just annoying that you're subscribing to when buttons fire. And I know why they're doing it. They're doing it because multiple things could hypothetically listen. But I don't like that. They're basically saying, let's not isolate all the input in one place, distribute it so that you can have really cool systems where when you turn on this object, it takes over input for a while, then you turn it off, and then this object takes over input. It gives you a lot of flexibility and freedom, but you're intrinsically, one, separating input around your app, and two, you're having to sort of tie this event architecture when, truth be told, efficient engines poll for input. Not as sexy and it's a bit messier to work with, but get state of controller, wait till end of frame, get state of controller, start of frame, compare previous state of controller to current state of controller. That constitutes the input. That's sort of the clean and fast way of doing it. And event systems are sort of a nice architecture, but again, you're paying the cost of doing that. So it's a decision they made, and I'm not saying it's good or bad. I'm just saying that you have the same problems that Unity does. You have to look at the solutions, look at the problems, and try to fit the right one to what you're doing, you know?
Definitely. Alrighty. Well, I think we did an hour and a half here. I think it's a good place to wrap it up.
Yeah.
Well, an hour and 20 minutes. But what are you gonna do?
Yeah, we covered surprising a lot more than I thought we would.
And we didn't even get to a code review, so we.
No.
Well, I guess we're gonna wrap it up here. So basically, to wrap it up, if you would like to have your code reviewed, that's something we try to do in these streams when we can get to it. I'm thinking about switching that to like a monthly thing, like maybe once a month we'll do a stream where we do a code review.
Yeah, because
there's a lot to consider.
No promises, but because the problem is that it's very, I don't want to say labor intensive, but there's a certain level of, we're not just reviewing your code as like, oh, here's the thing you can change. It's not about solving a problem. It's about trying to both find the problems, try to provide explanations for solutions, try to write solutions, and then try to make the solutions understandable as video content. And so sometimes it's just too difficult to come up with all of those, to solve all of those problems, to cycle back to the metaphor from earlier.
Yeah.
So I think it might be a good idea to sort of push code reviews a little bit as like a rarer concept.
Yeah. And but it's really the biggest thing is that we want to provide as much quality educational content as possible with these code reviews. I don't want to just open up someone's code and be like, oh, he named his variables like this. Like, I can't even read this, like it's.
Plus, it's also, it's like, it gets a bit repetitious. Like, it's not anyone's fault. It's just, there are common mistakes. And we either end up having to ignore ones that we covered before, which isn't helpful to the person we're helping, or we repeat them again, which isn't helpful to the viewers in general. So I think my personal preference is, if you provide code to be reviewed, you may not literally review the exact code you gave us, but if you have a problem that's outlined in the code that you're kind of having trouble firing events between two classes, you might take inspiration from that if it's a repetitious problem that multiple people seem to be having, and it might be something we'll come up with an example on stream that will cover that idea in a way that you could replicate in your own project. That might be a more valuable way.
I think that might be the way to go too. But that being said, that sort of thing takes time, so which is why we might limit these to once a month or every now and again. Maybe not. I won't even commit to once a month. I'll just say whenever we get a good one roll through, and we can come up with an example, then we'll do it. But that being said, if you'd like to submit your code for review, submit at infalliblecode.com/code-review. There will be a link in the description. If you haven't caught my most recent video about singletons, definitely want to check that out. Drop a like and a comment on that if you like it, or I guess a dislike and a negative comment. Hey, I'll take any engagement at this point.
Feed the algorithm.
Feed the algorithm. And then on Sunday at noon Eastern Standard Time, I'll be posting up my weekly video. And this week we're going to be doing another installment of my monthly productivity asset reviews. So check that out. Should be good. Other than that, we're going to be streaming once a week. Can't give you a time because I just haven't picked one yet. So it'll probably be around this time, but on either Tuesday, Wednesday, Thursday, or Friday. Not Monday. Definitely not Monday. Can't start my week off with a stream.
Yeah, exactly. Not at your best on a Monday.
No. I'm barely at my best on a Friday. So thank you guys for joining. Had a good time, good conversation, and I think we'll catch you in the next one. Laters.